Why are tunnel boring machines buried on site after completing a project? Today we're going to tear this behemoth down to its very last gear to see exactly how it works. Many people think a tunnel boring machine drills holes, but it's actually crushing rock. At the very front, this rotating steel disc, measuring up to 15 meters in diameter, is studded with dozens of incredibly hard tungsten carbide discs. We call these disc cutters. As the cutter head rotates at a painstakingly slow speed of 3 revolutions per minute, the hydraulic cylinders in the back apply a terrifying thrust of several thousand tons to it. The disc cutters have no driving force of their own. They passively roll against the rock face. This extreme contact pressure instantly exceeds the compressive strength limit of the rock. The rock fragments then crumble and flake off like a crumbling cookie. So how does the tunnel boring machine get its forward thrust? This brings us to the origin of its name, the shield. This is an indestructible cylindrical steel shell. It not only protects the workers inside from being crushed by millions of tons of rock and soil, but it also serves as the load-bearing core of the entire machine. Hidden inside the shield are hydraulic propulsion cylinders, but for the hydraulic cylinders to push forward, they need a solid fulcrum for recoil. In the muddy underground, where does this fulcrum come from? The answer is the wall it builds itself. These hydraulic cylinders press dead hard against the already assembled inner walls of the tunnel behind the machine. Accompanied by the roar of the hydraulic pumps, this massive thrust forces the multi-thousand-ton TBM forward into the rock layer. After the hydraulic cylinders have pushed the machine forward by 2 meters, the cutter head must stop rotating, because next, this mobile factory has to start automatically assembling the tunnel. The hydraulic cylinders retract one by one to free up space. At this point, the giant robotic arm of the segment erector kicks into action. With millimeter precision, it presses multi-ton precast concrete segments perfectly against the tunnel wall. Then, workers lock them tightly in place with massive bolts. Usually, 6 to 7 segments, plus a tiny wedge-shaped key segment, can form a perfectly load-bearing ring. Once this ring is fully assembled, the TBM's hydraulic cylinders will press against this brand new ring to begin the next round of excavation. So where do all the crushed rocks and dirt excavated from the front go? If they can't be cleared out, the TBM would literally choke itself to death. So engineers installed a massive screw conveyor inside the excavation chamber behind the cutter head. When the front is under high pressure, this screw continuously transports the crushed rocks to the rear. They are then pumped through pipes to the tunnel entrance miles away. So why bury it on site after the project is done? First of all, a TBM is absolutely massive, dozens of meters long and weighing hundreds of tons. In a narrow tunnel, it is completely impossible to turn around, let alone reverse all the way back out. Hauling it back up to the surface would cost an astronomical amount of manpower and money. Secondly, it's only the TBM's outer shell and cutter head that get buried. These parts suffer severe wear and tear during construction and have almost no reuse value. Meanwhile, the internal precision components have long been recovered by the engineers. Therefore, burying the shell and cutter head on site is the most economically sound choice. If you understood this, drop a like and follow me. Next time, I'll bring you another hardcore teardown from a mechanical perspective.